So I'd like to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and the webinar today is really an exclusive webinar for our users in the Asia Pacific region. The idea behind this is we get a lot of comments from users saying, we'd love to attend the webinars, but they're not in our time zone. They don't work for us using our typical times. So what we thought we'd do is put together a webinar specific to those users in the Asia Pacific region that fits your time zone and allows you to ask any questions. So this is really your opportunity to ask any questions you'd like. What we thought we'd do today is put together a webinar to kind of give you an introduction into Onshape and some of the key things that make it different from many of the CAD systems that are out there today. So again, feel free to type in any questions that you'd like. You have a questions dialog and you go to webinar panel. Type in anything you'd like, and I'll do my best from time to time to stop and address them. Also on the line is Darren Henry. He's available for any questions as well, so we're going to try and make sure that everything is addressed. Any questions you have are addressed before we end things today. So without further ado, let's jump into it. Now, the idea today, again, is just kind of a high-level overview of Onshape and why we went about creating a new CAD system. So I'd like to get into, first off, how CAD is changing. You'll see the CAD landscape is evolving, and you'll see that there's a very fast adoption of cloud-based services. So how CAD is changing and how this impact affects you and why it matters. What's the difference between how you may be doing things today and Onshape's approach. And then I'd also like to get into an introduction into Onshape. Real simple introduction, how it works, build a simple part, assemble it, and really try and highlight some of the differences between Onshape and the software that you may have used in the past. So that's really the agenda, is really trying to give you kind of a high-level overview of Onshape. I also would like to get into a few key things that are really different about Onshape. So let's get into how CAD is changing. Now, in order to look at how CAD has changed, we have to go back a bit and look at how CAD has evolved. And if you've been around CAD for some time, you may have seen some of these CAD applications that are out there. But going back to 82, for example, the prevalent CAD system out was Autodesk and AutoCAD. So if you looked at the price model, it was about $5,000, and this was in 1982. And of course, it was a 2D CAD system. And in roughly 1988, we had PTC. That was almost $20,000 direct sale, and it required a very expensive Unix workstation. Then in 1995 came SolidWorks, and SolidWorks was rare because it was $5,000, relatively cheap for a 3D CAD system, but it also ran on the standard desktop that everyone had at the time, which was the Windows PC. So that's kind of how major CAD systems have evolved over time, is they've grown to be more consumer friendly and less cost. And you'll see this is kind of following a trend when we start talking about Onshape. So this is kind of how it got started. Now, the problem with these software packages and these approaches is they're really based on an old system and an old management system for how we manage the data. In terms of AutoCAD, PTC, and SolidWorks are all file-based CAD applications. And the issue with a file-based CAD application is that it's very difficult to collaborate. When we start talking about design teams, things change often. I may not be sitting in front of my desk. These teams may come in and out. I may, work with different vendors on and off depending on the projects that I'm having. So there's constant change. And this change means that working with file-based systems is just not that practical. When we start talking about trying to create a faster time to market or build innovation into our systems, we need to be able to evolve very quickly. And so one of the things I always like to show users, if you have experience with a traditional CAD system, you'll feel my pain here, is that, of course, you have each user has a CAD system. They have to install, download, and maintain that CAD system. It runs on a very specific computer, right? Windows only traditionally, and as mentioned before, it's generally $4,000 or $5,000 up front to buy it. You then have to download and install it, maintain it with your own service packs. You have license codes and servers you have to maintain, and then you have to deal with files, and in particular, how to manage those files. So this has been one of the biggest headaches. When you need to work with someone, you have FTP, you have email, you have flash drives. There are all these different workarounds, even creating dedicated file servers and PDM systems. So there are these whole ecosystems that evolve around data management and file management. So the biggest problem with this is just the sheer amount of copies. Because you're working with all these individuals, you end up copying several different instances of the file everywhere. And it often leads to who has the latest version, or, what version am I working with? So, um, you know, there's all kinds of solutions. Whether you're using Dropbox or Google Drive, you're using flash drives, FTPs, there's all kinds of solutions users have today for sharing files, but they all share one thing in common, and that is you're sharing a bunch of copies of files. And there's a number of issues that come from this, but this is one of the biggest struggles many users have today. And so what we wanted to do with Onshape is take a different approach to a CAD system. And so the idea behind this is, instead of all these copies going around, back and forth between all the different various teams and the engineers, what if everyone worked on one data set? What if everyone was working with the same, data at the same time? Rather than exchanging files and overwriting references and dealing with corruption and all the issues associated with it, what if there was one set of data, one version of the truth? What would that look like? And that's the idea behind Onshape. If you're just getting started with Onshape, the idea behind it is it's full cloud CAD. It runs entirely in a browser, and there's one version of the CAD data. So everyone's always on the same system, everyone's always on the same version, and there's never any copies. So that's really the idea behind Onshape, is eliminating a lot of this headache of many traditional file-based CAD systems. Now, a bit of background on Onshape. It's the only company right now that's focused 100% on building a professional CAD system that runs in a browser, a full cloud CAD tool. It was founded in 2012 in Cambridge, Mass. 144 million in venture capital, so one of the largest CAD companies, startups ever. Venture capital firms from just about everywhere. 100 plus employees, including the original SolidWorks team. So many of the SolidWorks founders, R&D, and so on, have moved to Onshape, right, to build this next generation CAD system. And then we also have a number of experts in cloud, data center, security, and so on. So that's just a quick background in Onshape. What I'd like to do now is just give you a brief demo of it. So let's jump out of Onshape itself, or excuse me, of the slides, and jump into Onshape. Now, as I mentioned before, Onshape runs in a browser. It's entirely within the browser. So you're going to see tabs across the top, and I log in through the Documents page. So if you haven't had a chance yet to create your Onshape account, I definitely recommend it. Once you create your account and log in, you'll be greeted with the Documents page. You can create as many documents as you'd like. Again, keep in mind, a document is a project-level container. So one document can hold as many parts or assemblies as you would like. Right? So an example of this is the bike frame. And I have the bike frame open here, the bike frame assembly. And you'll notice that this document has several pieces. This is an assembly with the frame and some shocks and so on. And there's several different components to this assembly. Each component is held in a tab across the bottom. Right? So parts, sub-assemblies, even imported parts. This is an imported swing arm. Here you'll see this was imported from SolidWorks, right? And even files that I've imported just for the purpose of storing all the data in one place. Here's a PDF that's related to the project, right? So project-related files, parts, assemblies, drawings, all together in one location in one document. Now, what I'd like to do is take you through just a few basic CAD creation tools. Now, if you have experience with many of the CAD applications that are out there today, much of this is going to be familiar for you. A lot of what you see in Onshape is very much a carryover of what exists in many traditional CAD applications. Now, there's some opportunities we've taken to improve the experience, but for the new user that's coming from another CAD system, it should pick it up fairly quickly. So let's get started. Now, in this case, we have our default planes, front, top, and right. If I want to start a sketch, I can left-click a plane, hit the sketch button, and I always prefer, just a little tip, the right-click menu. The right-click menu in Onshape has a number of different useful things, and in particular, the View Normal to Sketch Plane command that allows it to rotate around. Now, for those out there that are keyboard shortcut fanatics, you really like your keyboard shortcuts, those options are here under Help. We do have a full list of keyboard shortcuts for parts, sketches, drawings, assemblies, and so on. Now, what I'd like to do, now that I'm in a sketch, is start sketching some geometry. So I'm going to start with a few circles. We'll start with a simple circle command. And as I mouse over the origin, you'll notice I get that visual cue that I'm attaching it to the origin, creating a constraint. I'll left click, and I place my dimension. I'll do that one more time, this time to the right, left click, and now I've placed a second circle. So again, very easy to go in and add a few dimensions, or excuse me, a few circles, and add maybe just a few dimensions as well. One thing I want to point out as I add my first dimension, I'll select dimension and select the circle. We'll go ahead and enter a value. Okay. Notice that the sketch scales to match my first dimension, and also notice that the circle on the left turns black. So you get visual cues as to the level of definition of your sketch. In this case, the circle on the left is fully defined, the circle on the right is not. Right? So it's very easy for me to see that just based on the visual cues, for the two different colors. So now what I'd like to do is add another dimension here. Okay. And then we'll add a dimension for the distance between them. Okay, so now I've gone back to a fully defined sketch. You'll see the circle on the right is also fully defined. So the next thing I'm going to do is just draw a few simple lines. What I'd like to do is create the link for our mountain bike frame that I showed you just a moment ago. And for this, what I'd like to do is mirror this line. So just a tip for those users out there, we do have a mirror command in the sketch level. And the key thing with a mirror is you want to use a construction geometry as a reference. All right. So the key thing with a mirror, you select the mirror command, you select your mirror line, and then the line or the entity you would like to mirror, can be anything, and then it mirrors it to the other side. So it's very easy for me to create a set of mirrored lines that behave with symmetry. You see as I drag these, they're symmetric about that construction line. Okay. So very easy to go in and add those constraints. The last thing I'll do, of course, is add just a few dimensions. Okay. Now, one last thing I want to point out with this is I can have as many nested contours in here as I want. And I don't have to worry about trimming entities or cleaning up sketch geometry. I don't have to be concerned with those types of things. It's very easy for me to add extra circles or extra lines and not have to worry about, is it one closed loop, or did I go in and clean up all the sketches so that I can extrude it? With Onshape, you can extrude a piece of the sketch, the entire sketch, really any combination of them. Right? So I've got my fully defined sketch. I'm ready to create an extrude. I'm going to go ahead and click extrude. We'll rotate the model around just a bit here, and we'll extrude this 25. Okay. So very simple. You set your depth, green check, and now I have my first extrude feature. Okay. So very easy to do. Now I want to do one more step to this and then we'll move on. And what I'd like to do is create a new sketch on the top plane. Okay. And I'm just going to draw a few lines. Add a few dimensions. Notice that I don't need to use a special tool for angle dimensions. Just select two lines that aren't parallel and it automatically assumes that you want an angle dimension. Okay. Now, what I'd like to do here is offset this. And this is just another tip for those users out there. I have 3 lines. And we have an offset tool. It's very easy to use. You can select your line and it offsets just the one entity. Okay. However, just a tip, if you select offset and you left click and drag. So rather than left clicking an individual line, left click drag, you get the entire chain of geometry. So if you have 5 or 10 lines or arcs or whatever it may be, you can left click and drag and it will offset the entire chain. Right? So left click in space, we'll enter 8 for the offset, and we'll sketch in a few lines to close it. Now, also very useful in Onshape. And again, if you've come from a traditional CAD system, you'll recognize it is the use command, often referred to as convert. And convert can be very useful for taking existing geometry, for instance, the silhouette of this arc, and converting it to sketch geometry. And this is nice if I want to attach something. For instance, I want to attach the edge of my sketch to it, because it makes it very easy to select the silhouette and then constrain my geometry to the outside of it. Okay. So one last dimension here. And again, we're back to a fully defined sketch. Now, I want to do one last extrude. Okay, and we're going to extrude this symmetric 25. Okay. And instead of doing add, which is the default, and it will add more material to this existing part, I want to point out the intersect option. And this will give us just the geometry that's shared between them, right? Just what geometry is intersecting between them. So again, just want to point out, you have pretty powerful capabilities in the extrude, revolve, sweeps, and lofts. You have all these additional options. One thing I always like to point out, especially for those that have experience with other CAD systems, is you won't find a separate cut command in Onshape. You find the remove option in extrude, revolve, sweeps, and lofts. So you just select remove to create a cut or add to add material, right? It's all depending what your goals are. But green check OK, and now I can see the finished link, right? So again, really just trying to highlight that, up to this point, we have the basic tools that you're used to: extrudes, revolves, sweeps, lofts, sketching tools. We have tools like fillets, for example. Very easy for me to go in and, apply a fillet and select a few corners here and add some radiuses to them, right? So it's very easy to do. It doesn't require, tons of effort or energy, especially if you've come from another traditional CAD system. Again, you should pick it up fairly quickly. Now, up to this point, a lot of what I've done would be considered standard in a traditional CAD application, right? Now, remember that we're running all of this inside of a browser, so that in and of itself is a pretty impressive thing. But what this allows us to do is something we've never been able to do with a traditional CAD application, and that is be able to share with someone and really collaborate. So what I'd like to do is share this document. And just real quickly, I'm going to share this. I'm going to share this with myself and with Darren. So I'm going to go ahead and type in my email address. And I want to define my permissions. A very important step. So if you haven't shared your document yet, I definitely recommend it. But go through and look at the permissions. We have permissions for can edit and share, which allows the person you're sharing with to edit and also share the model. You can give them permission to edit, the ability to view, comment, copy, and export, view, copy, and export, and simply view. So you really do have very granular control over how you want others to access your document. Now, keep in mind, every new document you create by default is private. So no one else can see your document until you share it. And the neat thing about this is, unlike sending emails with file attachments and things like that, you can also unshare. So you can remove permission to your document at any time. So you define the email address, you define their permission, you hit share, and they're given immediate access to your document. They don't need to download or install anything. You give them instant access. In fact, you can actually get visual cues when they're in your document. So you'll see here, I have the C indicating Cody's in the document, and I can even see when they jump around in tabs that they're creating features, for example. So here's a shell, and as you see, as I create that, I get new feature being added. I can select, let's add a shell to this. Okay. And the moment it's created, I see it. So I'm seeing, in real time, the work between us. There's no delay. I'm not waiting for someone to check in a file or have to deal with any of those kinds of issues. Okay, so I mentioned real-time collaboration. You have the ability to work together, and maybe you want to assemble things together. You want to piece together the assembly, or maybe you're just looking for feedback. Another great example of this is just looking maybe for feedback, or maybe, I'm sharing with the shop floor and we need to collaborate, and not in the sense of maybe simultaneous editing, but I need to share with the shop floor so they can give me feedback about a hole size or a fillet size, for example. And so another example of sharing is the feedback tools. They allow us to communicate with each other. So it could be maybe we're collaborating, via um, a phone call, maybe a video message, and inevitably, I want to see, what fillet you're talking about or what hole you're talking about. I don't have, I can't see the issues you're talking about. How do I convey to the end user what it is I'm referring to? So I've just shared this document with Darren. And what Darren can do is he can go in and tag features with comments. And this is a unique way for us to add feedback or comments inside of the design. So again, you'll notice now Darren's in the document. You'll see the letter D here. So again, you get the visual cue that someone else is in your document. But the neat thing about this is he can go in and add comments. I can even see his screen. If I double click on his icon here, I can see his screen in real time. So he can point out the hole that he's referring to. And I say, this is the issue I'm referring to. He can point out any issues he may be having with the model, and I can see it exactly as it is. And the moment I left click anywhere in the graphics, it instantly takes me back it takes me to the exact orientation that I was looking at it on his screen. So this is a very useful functionality for being able to communicate with others. All right, so follow mode is a very useful one that I always like to point out. Again, double click their icon, you're seeing their screen in real time. Another element to it is comments. And you'll notice if I select the comments icon on the top right here, Darren's added a comment. And what's really neat about this is it'll actually highlight the feature associated with the comment. So if I select this, it actually takes me to the same orientation he was in, and it highlights the face he's referring to. So I can see he says, should we fill this hole? And he selected the face as the feature associated with it. I said, no, it's fine. Right? So it's very easy for us to communicate inside of the document and have these notes or these comments inside of the doc. Right? We don't have to have 3 or 4 different applications. We don't have to go back and forth. And it kind of gives us that one place to communicate. So comment capabilities, the follow mode capabilities, these allow you to really collaborate in real time, not sending emails with screenshots back and forth and then sending files back and forth and replacing references. These are the techniques that people have been using for 20 years, and it's just really an outdated workflow. So those are just some of the collaborative tools I always like to point out with Onshape. Really encourage you, if you haven't already, to share your document and try them out for yourself. Whether you want to share your model just to view, or you're looking for someone to help you assemble, or there's all kinds of neat reasons to share. And it's very easy to do. And the neat thing is, unlike a traditional CAD system where you then have to send them a viewer and they have to download and install something, with Onshape they don't have to do anything, right? They click a link and they're looking at the same model as you are, right? There's no work for them in terms of downloads or installs or anything along those lines. All right, so let's move on. Now, those are just some of the collaborative benefits. The next thing I want to discuss is one of the benefits with regards to assembly. So I'm going to jump into an assembly tab here. And what I'd like to do is just give you a brief overview of how we handle assemblies in Onshape, because the idea behind it is a bit different than many traditional CAD systems. And so I'd like to walk you through it. With Onshape, we use a higher level system of mates. And the idea behind it is, to simplify the number of mates that you need. So instead of, your assembly tree listing hundreds of mates when you really only have a few moving parts, or, those kinds of things really don't exist in nearly to the degree they do in a traditional CAD system, as they would in Onshape. So let me walk you through this. Now, the first step, of course, is to insert a part. Right? So I'm in my assembly. I'm going to insert my lower link. Okay. Now, just a tip, when you first insert your part, right, it is not fixed in any way. So it's just floating around. But what's nice about this is you can left click, and if you want to move it more accurately, you can rotate with the triad. You can move in a linear direction with the triad. So if you're looking for accurate motion, you just left click the part. But you can also left click and drag to move it around. Now, of course, the real goal here is to add a mate and actually put this thing in its place. And, Onshape assemblies are really all about motion. How do we test and figure out the level of motion that this thing needs? So what I'd like to do is add a mate, right? So let's move this thing around here. And I'd like to mate this part to the frame, right? So this part here to the frame here. Now, if you've come from a traditional CAD system, you may be familiar with a process that takes 2, sometimes even 3 mates to get one part in its place, right? Because if you think about it from a degrees of freedom perspective, you oftentimes have to restrict 1 degree of freedom at a time and then move on to the next one. And this can make a process of like mating a bolt to a hole, for example, 2 or 3 mates for something as simple as mating a bolt to a hole. So the idea behind Onshape is we wanted to take a little bit of a different approach. So rather than selecting faces as references and things like that, we use what we call mate connectors. And the idea behind mate connectors is you can think of them as a coordinate system or a point that are on your part. And what we do with Onshape is we take a point from one part and a point from another part, and we bring them together. The degrees of freedom of the mate are defined by the mate type. Right? So this approach, once you get used to it, is a far faster approach than something you may have used in a traditional CAD system. So let me show you what I mean. Now, again, I want to attach the link to the frame, but it still needs to be able to rotate. Right? So there is still some movement there. That mate is a revolute mate. So you'll see the revolute mate in the toolbar. I select revolute. I can select the mate connector. So as I rotate my part around, you'll notice all these little points appear. I select that mate connector, rotate it around, and select the mate connector that I want to attach it to. So again, really just think of it as I'm taking this point and I'm merging it or bringing it over to this point. Okay. Now, I mentioned before the degrees of freedom are determined by the mate. This is a revolute mate. And one easy way to see the degrees of freedom is to hit play. Right, you'll see an animate button there in the mate dialog. You'll see that this is free to rotate. So it'll animate the degrees of freedom that you have left in the mate. So it's a great way to see, how much motion do you have? Is this the correct mate, or is this what I'm trying to accomplish? Now, a tip for those new users, you can change the mate type. So I can say, okay, well, let's see what a cylindrical mate does. Right, cylindrical, play, and you can see it's free to spin and it moves in a linear direction. So there's one more degree of freedom. If I set this to fasten, hit play, nothing happens. With fasten, we've restricted all degrees of freedom. So the great example would be mating a bolt to a hole. That's one mate in Onshape. But you can play with the different mate types. You can try them out and see, is this the correct motion that I'm looking for? And you don't have to exit the command and go back in it and, and so on. So I'm going to choose Revolute. I hit the green check OK. And of course, there is my part. And if I grab it and drag it, you'll see it's free to swing around the frame, the pivot point that it's attaching to the frame, but it doesn't move in any linear direction. So one mate and the part is in place. Okay. We can do this one more time. We'll do a cylindrical mate. We'll select the other mate connector on the other end of the link and the arm that it's attached to right there. Now, one thing to point out, you'll notice here that this link has moved down. It's appeared to even broken this mate, and it's important to point out with Onshape, we're only solving for the active mate. However, you can click solve, and it will solve for all mates in the assembly. Okay, so if you ever add a mate and something doesn't look quite right, you can hit solve, and it will solve for everything and give you an updated preview. So I hit the green check OK, and now I've actually added my cylindrical mate. Okay. Now the key thing here, the key test here is of course motion. So now if I grab and pull on this, it should behave like I'd expected, right? It should swing up and down like I'd expect. Now, the key things with mates, in assemblies in general, is they're really all about motion. So when we create assemblies, we're putting them together to test out motion. And so with our mates, we've tried to take a different approach that saves you time. Instead of 2 or 3 mates to get your part in place, oftentimes it takes 1. right? You can restrict all degrees of freedom, fix a part in place with a single mate instead of a combination of mates. So that's just one quick overview, one quick example of Onshape mates and, just the different approach that we're trying to take. Now, one last thing I want to mention about general Onshape use before we get into a few of the advanced features I like to point out is drawings. And drawings are a key part to really creating a professional 3D CAD system, the ability to create production-ready drawings that are ready to go out on the shop floor. The neat thing about Onshape drawings is they're just another tab in your document. So I can click Create Drawing. I can choose from templates, right? I have several options for templates. Worth pointing out, you have Onshape provided templates. You can import DWT files as templates. So if you have some DWT file templates, you can import those as well. But we have a long list of templates to provide or that are provided for you. And I hit OK. It creates a new tab in the document, and I can start building my drawing. And it's very easy for me to select the front view, for instance, and drag and drop it. Right? We can project off of that view to create other views. So there's all kinds of neat capabilities. I don't want to spend too much time going into the drawing capabilities just because there are a few other things I wanted to mention here today. But again, front, top, and right, I can go in and start adding my dimensions. Right. So we'll add maybe a detailed view to the corner here. Okay, section views, all the different various dimension tools. We have tables as well, tolerance symbols, and so on. All right. So I wanted to mention some of the things that really set us apart. Now, I've discussed basic drawings and assemblies and all the little things that really set us apart. But when we really start to break down all the various benefits, one of the biggest is the fact that with Onshape, you don't have to worry about version control or data management or managing files or any of those types of things. And there are a number of elements I want to point out to this, but the first is creating a version. So let me jump back just real quickly here. Bear with me for a moment to my slides. One of the biggest advantages to Onshape is the fact that you don't have to worry about managing files. With Onshape, we work with Onshape documents. The idea of managing individual files goes away. Also, a big benefit to this is you don't have to worry about PDM systems or separate data management systems just to manage those versions or those revisions in your design. With Onshape, that's also built into the core. So within Onshape's CAD capabilities are also a really robust version management capabilities. Now, the way to think of versions is a view-only snapshot. So I often tell users, with a version, think of it as something you would want to be able to go back and look at some point. Maybe it's revision A, or maybe it's just some milestone in your design, and I want to be able to go back and look at it, maybe download the models at that stage. That's a great example of a version. And they're view-only, and they're a snapshot of everything in the document. So the parts, assemblies, drawings, even the PDFs and miscellaneous files that I've imported get version controlled, right? So just keep that in mind. It's a view-only snapshot. It captures the state of everything in the document, and it's a great way to go back and look at previous versions and even download the data at that state. Now, let's get into an example of it. Now, it's very easy to do. In fact, this is one of the easiest things that you can do in Onshape. There's a button right here. It says Create Version. Right? So I can click Create Version, and we create a version. Right? Give it a name. You can add a description if you'd like. We even have the ability to go in and add metadata and properties within the individual parts at this stage as well. But that's it. It creates, again, it captures a snapshot of the entire document. Now, the question you may ask is, well, how do I access this? How do I get to it? And there's the Versions Manager right next to it. So if I select the Versions Manager, you'll see Main and Initial Release. Initial Release was the one I just created. Now, the neat thing about this is I can left-click on it in the list, and it goes to that version at any point in the future. Right? So I have another example of this. Let's jump over to my other example here. Here I have Main, which is current. Well, as of January 20th, it was current. But I have Revision A, and Revision A was created in August of last year. And if I left-click Revision A, you're going to see a significant difference between this model and way it is today. So if I move things over here, you'll see there's no big round boss. The part is substantially shorter. The cuts are a bit different. So again, I mean, I'm seeing the major differences between main, which is the last modified January 20th, and this revision A I created in August. Now, the question inevitably comes up, well, there's 6 or 8 months difference between these, how do I tell what exactly has changed? How do I see what exactly has changed? There's a few ways you could do this. So let me jump back real quickly here. One of the first, and it's one of the big things I always like to point out with Onshape, is you have history. History, the way to think of history is an infinite undo list. Because, again, this is a web-based system, every little change that you make is tracked in history. And the neat thing about this is you can undo back to any moment. I can go back to any day that I've ever edited this model and restore back to it. Right? So I never have to worry about breaking the model. Right? If I get to a good state and I want to explore some things, I don't have to worry about, oh no, will I leave myself with a broken model in the end? I can always restore back to any point. So that's one of the first ways, history. And again, history is every change you've ever made to the model since the very beginning is listed in the history, and you have the ability to restore to it. But if you want something a little bit more specific, you can do a compare, and compare is particularly useful. So let's say that I wanted to compare the model today to revision A, which I was looking at just a second ago. Okay? What I'm going to do is choose revision A under the gear dropdown, the compare command. I select compare, and now I'm comparing the model today to revision A. And there's 2 things to note here. First, you get a list-based comparison, and then second, you get a graphical-based comparison, a graphics-based comparison. Both of these are very useful. I'm going to spend just a second going through them, but the neat one, at least from my perspective, is the list-based comparison. It really gives you a very granular, very detailed breakdown of what's different. So I can see that sketch 1 is not the same between those two. If I left-click extrude 1, it's also not the same, and I can see exactly what's different. In main, in the current version, the extrude depth is 20, but in revision A, the extrude depth was 22. So I'm getting very specific breakdown. If I select a fillet, for example, I can see that in main, there's only 4 edges, and it was a radius of 4 millimeters. But in revision A, it was 6 edges, 5 millimeters. Okay? So just keep in mind, you're getting a very specific breakdown, a list of everything that's different. Also, you get a list of things that exist in one and not the other. So fillet 7 exists in revision A, does not exist in main. Right? Chamfer 1 exists in the current main, but doesn't exist in revision A. So again, you get a really specific list of everything that's different. That's the list-based compare. Also with this is the graphical slider. Right? And this is just really cool. It's not as detailed, but if you're just looking for a real quick, just drag the slider, show me what the difference is. This is the tool to use. Right? Grab the slider and drag from one end to the other, and it gradually transitions between the two. Okay. So that is the compare tool, and it very much ties in with the versions, which I was talking about just a second ago. You can compare 2 versions. You can even compare moments in history, which again I was talking about a second ago. So you can go back to your model 6 months ago and say compare to today. But also with this ability to create versions and this ability to compare is what we call branching and merging. And this is a really powerful capability that really sets us apart in terms of professional CAD systems. This is something you simply can't do with a traditional CAD system. So if I go into my example here, I'm just going to jump back to main. And I want to create a branch. Now, I should point out, I'm going to show you an example of branching and merging, but really these things can be used independently. You can create as many branches as you want and never merge them. Right? So it's important to understand these are 2 totally independent commands. They don't have to be used together. But these 2 commands used together really add a powerful capability to Onshape. Now let's just say here's my arbor press design. and I've created my initial release. You remember a moment ago I created a version called initial release. But now what I'd like to do is explore two design variations of this release. Let's say that this was revision A, now we're ready to make revision B, and we want to explore a different base for this arbor press. Now, how do we accomplish that? We can both work together on the same model, but what we can also do is create what we call a branch. Now, an important thing to keep in mind with a branch, you must branch off an established version. I created that initial release earlier. I can't branch off the active. In this case, would be main. So I'm going to select initial release. I'll choose branch to create workspace. We'll call this base with tabs. Right. So I'll create the base with tabs. You'll notice I get a little graphical indicator that you've created a branch. So you get the preview here that this is in fact a different branch. And I'm going to do this one more time. We're going to create two different branches. We'll call this the square base. Okay. So I've created these two different branches. Now, the important thing to point out about branches, these are totally independent workspaces. So a change made in Squarebase does not affect base with tabs, right? So it really allows us our own sandbox, our own place to edit the model without worrying about affecting each other, right? So it's just a different workflow. But if you like that idea of, being able to branch off in my own little space, build my model, and then merge it back with the main branch, this is the workflow for you. Now, I do want to point out that I have Squarebase, I have base with tabs, but I also have a main branch here, and you can continue editing that main branch. So I can go in and edit or remove or delete features. So for instance, I can delete these fillets or chamfers, and you'll notice I get a visual cue that it's the last edited. So if I go back to that version, I can say, okay, the main was the last one that was edited. Okay. Now, if I jump into another one, let's go into the Squarebase. Okay. What I'd like to do with this one is edit the base design, right? So let's go back. What I'd like to do here is I want to change this base. We're going to get rid of these. I'd like to change the base to where it's just a square shape. Okay, so let's jump into this. Rotate the model around here, and all I'm going to do is make a simple change to the very first extrude feature that drives this base design here, so that we have a square base. Okay, and again, just trying to highlight that everything I do here only impacts this branch. Okay, so once I select the contours that I want to extrude, again, remember with Onshape sketches, you can select any piece of the sketch or the entire sketch, right? So now I've modified that first feature. We'll let it rebuild there. And now I have a square base version of this, right? So now I have the square base. Let's jump back. This time, we'll go back to main. Okay. And again, you can make as many changes as you'd like. So I can keep editing that main version while others are being edited. One person can work in one branch, another person can work in another. It's entirely up to you how you decide to piece these things together. And I can go into base with tabs, for example. So we can be working in independent workspaces on the same project. And it's entirely up to you how you decide to structure that. Now, what I want to point out is you'll notice now I have a version called base with tabs that has tabs here. If I go back into the branch or the versions here, select square base, now I have a version with a square base. Okay. And if I go to main, I have my initial main version. Okay. So just keep in mind you have three independent spaces with which you want to work, with which you can work. So the last thing I want to mention is, I have all these are all branches. And you can create as many branches as you would like and never merge. So I can have these branches and they can exist by themselves and keep editing and move on, and I never have to merge them. However, let's just say that I want to take some changes from one of these and merge them with another. Right? So let's say I want to take the changes from base with tabs, for example, and merge them with main. You can select, in this case, the way to think of a merge is a from to. I want to take the changes from base with tabs and push them from here to main, right? So I select main, that's the active, and then in the gear dropdown, you'll see the option merge into current workspace. And what that will do is it will merge the changes from base with tabs into the current workspace. Now, there's a bit of explanation that goes along with this, so bear with me for just a second. Now, the question inevitably comes up, well, that works fine when there's no conflicts. And here's an example of that. So I have, the feature here with the hole in it, and I have the boss with the radiuses. And of course, you end up with a, boss with a hole in the radiuses. So everything works out well there. But what happens if there's some kind of a conflict, between the versions? For instance, here's an example of a chamfered edge. Here's an example where that same edge is filleted. Obviously, the two can't exist once they're merged. One has to win over the other. And so there is some logic to how this works. Bear with me for just a second. I want to get into how this works, but in particular, just the rules of how it works. So the from branch, if in the case of features, for instance, in this example, I have a chamfer here and a fillet here. Because this is the active branch, that's the branch that's active when I did the merge, that feature wins in the conflict. You'll notice in the end, the chamfer exists and the fillet fails, right? Because there's a feature conflict. So for feature conflicts, the active branch wins. If there's a dimension conflict, you'll notice the height here and the height here, it's the inverse, right? The branch you're merging to wins in that case. So just to explain a bit of the merge logic here, but just something I want to point out is really something that sets us apart. Something you can't simply do with a file-based system is merge a bunch of changes from a whole bunch of people together into one, right? So that is branch and merge. I want to take one more moment while I'm in the slides and go over real quickly some of the advantages that we've discussed here today. So one of the biggest advantages, and I've already mentioned it just briefly, but with Onshape is accessibility. You're not tied to a very expensive workstation that only runs a certain operating system and is bolted to your desk. You have the ability to get to your CAD data from anywhere. You can even access your CAD data from a mobile device. So if you haven't downloaded the Onshape app for Android or for iOS, I definitely recommend it. It's a full-blown CAD editing tool, not just a viewer. So you can create parts and assemblies from your phone or tablet using Onshape. So accessibility with Onshape is a huge advantage. You're not tied to a single machine, a single licensed computer. But it also means sharing without file copies. You saw me share with Darren. You saw me share earlier very easily. Just enter their email address, define their permissions, hit the share button. There's really not much more to it than that. And they're looking at the same exact thing you are. So you're not sending copies of files around. You never have to deal with who has the latest version or when was that last edited or where is it or is that file corrupt. All those issues go away with Onshape. So very easy to share, never have to worry about files. Also, the ability to simultaneously collaborate. Again, because we're not using a file-based system, multiple people can work on the same model at the same time. 2 or 3 people can edit an assembly at the same time, or work on a part at the same time. Or you can work on your own branches like we just saw a second ago. Also, one of the biggest benefits of Onshape is just simple affordability. You're not spending $4,000 or $5,000 up front. There's no big upfront cost to get started with Onshape. It's $100 a month for the professional account, and you're in, and you have full accessibility to everything. So, really an affordable CAD application for those that are looking for something that's better than the $4,000 or $5,000 that you have to shell out up front. Also, because we're a cloud-based app and because we're less dependent on the hardware you use, we have far greater stability and performance. you'll never see crashes in Onshape that take down your whole computer. You'll never see crashes that cause corruption or cause your machine to overheat. Those issues don't exist because, again, much of the calculation is done in the cloud, right? Where the hardware is all the same and we have the exact same performance and we know what we're getting. So greater stability and performance out of Onshape. And of course, with all of this, without having to manage files, without having to manage installs, without all the headaches of sharing, you're able to focus on design. And if you're able to focus on design, products evolve faster, right? So the idea behind Onshape is allow them to focus on CAD and not all the headaches of working with CAD, right? So these are just a few of the advantages of Onshape. For those that are just getting started with it, we really encourage you to use Onshape with your teammates to review a design. I've shown you just a moment ago where you can use follow mode or you can use comments. You can collaborate in real time. Really encourage you to share a document with your teammate and use it as a design review tool. Maybe it's reviewing with the machine shop or reviewing with a coworker, right? You can use Onshape for really strong CAD data exchange. We can import and export nearly any CAD format. And remember, anything can be imported into a document. So even PDFs and spreadsheets and all the miscellaneous project files that you want to store with your project can be imported into a document. So you can use Onshape as a CAD data exchange tool. You can use Onshape as a tool alongside your existing CAD system, maybe just a tool to share. There's all kinds of great examples for it. Another example I always like to point out is, maybe your area doesn't have the funds to spend $5,000 up front for a CAD software. With Onshape, it's very easy to get started, which means it opens up CAD to a whole bunch of users that may never have considered using it. Think of the shop floor, the machine shop, or developing test equipment, and all these kind of ancillary jobs that are involved with engineering where they may be using, napkin sketches or 2D CAD softwares or really antiquated things. So Onshape has a lot of great niches inside the company that aren't just, the typical engineering using CAD. Of course, that's our bread and butter. That's where most of our users are. But there's a lot of potential for Onshape throughout the company. So that's really what I had planned. We're just a few minutes early. I'm going to stick around and answer any questions. So again, feel free to type them in. I want to say thank you, everyone, and have a good day.